All right, so I redrew this picture here for this example a little bit bigger. This is 1, 2, 1, and 2. Here's my table of values for t values versus x and y. And so you can see this picture here, and we have a direction. It started up here at 0, time equals 0, and 0, 2, and then it ended up right here. So I'm stopping there because the things that I am looking at are in the first quadrant. For instance, it says sketch the position vector. Well, this right here is a position vector. Okay, so the position vector is 1, 1. So if I go over 1 and up 1, I get this vector right here. That's the vector 1, 1. So it goes to right here. And look at that. It's basically this thing right here, right? It's your position after 1 second. And so that's where you are. And then if I sketch the tangent vector, so this guy right here, well, my tangent vector at t equals 1, so at this place where t equals 1 is going to be, so at this spot right here, so right here where I'm at, I'm going to sketch the vector 1/2, comma, -1. So from that green dot, I'm going to go over 1/2 and down 1, so over 1/2 and down 1. So it'll be the vector like pointing this direction, that completing that triangle. Okay, so I would sketch that vector basically like over, let's see, 1/2 down 1, so like kind of like that. Okay, and so that's the tangent vector, and so that is the vector that represents the slope of the purple curve at this moment of time equal 1. And so you see how that that green one, it's a tangent vector to that spot right there. And why don't we go ahead and write this down? This is a tangent vector at t equals 1. So after 1 second, I guess you could say. All right, so moving on, let's see. So find parametric equations for the tangent line to this helix with these parametric equations. So important part right here. So we want parametric equations, and we want those for the tangent line. So a tangent line, that means I'm going to need a tangent vector, and I'm going to need a point. Well, good. I have a point right here, right? So I have a point, and I'm going to go ahead and have to get my tangent vector. So I need to find r of t, right? So, or r prime of t. So r of t is given to me as 2 cosine t and sine t and t. So r prime of t, so it's nice to just like line them up and do it. Derivative of cosine is a negative sine, so I have -2 sine t. Derivative of sine is cosine. And then finally 1. So there is my tangent vector. All right, and so I need to know, I need to do it at this point. So this point right here that was given to you was x, y, and z. So in a sneaky way, they gave you the t value. So this is a point on this vector, or this curve, this parametric equation. And so in that sneaky way, what we have done, x is 2 cosine t, y is 2 sine t. Well, z is t. So by giving you a point on this curve, you've been told that you can get from this is that t is basically equal to pi over 2. So you have to watch out for that, because you need to plug pi over 2 into the other problem. And so you'll be doing these problems, you need to plug it in here and here. And you'll be doing this and be like, how do I know what t is? Well, they gave it to you earlier in the problem in kind of a sneaky way. All right, so we're basically doing r prime of pi over 2, because that's my t value at the moment in question. So sine of pi over 2 is 1, so I get -2 times 1, so -2. Cosine of pi over 2 is 0, so we got 0. And 1 is 1. All right, so there's my direction vector of the tangent line. And then we have the point that was given to me earlier, so we're just going to make up an equation of a line. So we do parametric. So x equals, let's see, -2. So -2. Why don't we use the letter a just in case, because we are using t quite a bit. But actually, never mind. We can use t. I was thinking. All right, so because actually we probably still should use t. All right, so 2t plus 0, because I'm getting a 0 right here. And then I have 0t from here and plus 1 from here, so that'll just be 1. And finally for z, I'll get 1t, so t, and then plus pi over 2. So it's kind of weird to have that little pi over 2 in there, but whatever, that's just what it is. All right, what's the second derivative? So we will do our double prime of t. So I just to show you this one. So I'm doing the second derivative. So I'm doing the derivative of the first derivative. So here's my first derivative. The derivative of that, the derivative of sine would be cosine. So I get negative 2 cosine t. Derivative of cosine is negative sine. And the derivative of 1 would be 0. All right. So why don't you pause the video and you go ahead and try it. We want to find the unit tangent vector. So we need the derivative, we need the magnitude of derivative, and we got to divide those. And so I'm going to show you a little something about that in a second. So you just try to do the basics, and then we'll clean it up when you get back. All right, so I'm assuming you paused and now you're back. So our prime of t would be 2t. Derivative of 4t would be 4. And derivative of ln t would be 1 over t, so I'm going to get 4 over t. All right, so I need the magnitude of r prime of t. So hopefully you at least found that. And so that would be the square root of all these pieces squared. So square 2t, I get 4t squared. Square 4, I get 16. And square the next, I get 16 over t squared. So let's clean this up a little bit. So let's get a common denominator. So I got a t squared down here, all inside the radical still. So that means that this 4t squared is going to have to get another t squared. So it would be 4t to the 4th plus 16t squared, and then plus 16. All right. So let's see. I can pull out 4. So let's do that. Square root. I still got t squared. Let me get a smaller pen here. Pull out a 4, which leaves me t squared plus 4t squared plus 4. All right. T to the 4th. Sorry about that. I made a little mistake there. Something was weird. All right, so this should be t to the 4th. Oops, I have to clean that up. So this should be a t to the 4th still here. There we go. All right, so that's factorable. You know, t to the 4th plus 4t squared plus 4. I can factor that into t squared and t squared and plus 2 and plus 2. And you notice everything works out, right? This is t to the 4th. I got 4 in the back. I got 2t squared and 2t squared to make my 4t squared. All right, so let's finish this up here. So we have the square root of, we got a 4 out here, we got a t squared down there, and this right here is t squared plus 2 squared. And look at that, everything is a perfect square. So the square root of 4 is now 2. The square root of that binomial squared is going to pop out t squared plus 2, and the square at the bottom is just t. So let's go ahead and write this as 2 separate parts. Let's see, on top I have 2t squared over t, plus the next part I have 4 over t. So to wrap this up, I got basically 2t plus 4 over t. This is my magnitude in case you forgot what we were doing. Okay, so basically what we're going to do for my unit tangent vector, t of little t, we're just going to say is this r of t, 2t, 4, and 4 over t. And we're just going to put it over 2t plus, how about 4t to the negative 1, so we don't have to write a fraction under there. Okay, and like I said before, just leave it like that. And usually what you'll be doing is put in a number into it or something, whichever. All right, this down here, these are just all those rules that you, some rules that you had in, what's it called, in calculus. So this should be a common rule too. Some of them are and some of them aren't. So if you have the derivative of two things added together, you know that you can just do the derivative of each one and add them. if you have a constant in your derivative, that constant can go out front, and you can basically then do the derivative of the item next to it. All right, so the derivative, this is like your product rule, right? So you have a function, and then you have what's supposedly a vector right here, but you notice this product rule, derivative of the first times the second plus the derivative of the second one times the first, okay? So here's where things get a little bit different. So this one up here is called the product rule. This next one, you notice, is a dot product. So this is called the dot product rule. All right, so when you do that, it's pretty much like the product rule above it, except that they are going to be dotted. So you'll have, and I guess, you know, it doesn't matter the order really, but because dot products don't really, you can do them either way. But since this first one's u of t, we'll call it u prime of t. Dot it with v of t plus, so these are both vectors now that you're dotting together, and then you have, of course, regular u of t dotted with v prime of t. And like I said, like these could be reversed, you know, dot products don't matter, they're commutative, you can do them in any order. All right, and then this next one down here is your cross product rule. So this would be quite tedious, right? So you have two vectors, you're doing the derivative of the cross product. So you have the derivative of one crossed with the original other plus the original crossed with the derivative of the next one. And so that one, it is important, the order that you do it in, because remember the cross product, if you switch the order of the cross product, then it's going to mess up your signs. All right, and this last one here, this is just like chain rule really. So this is like you have a vector with a function inside of it. So if you want to do the derivative, you do the vector of the overall problem, and then outside you do the derivative of the inside part that you didn't touch yet. All right, so we're going to do like two of these things, but you know, nothing too complicated. All right, so let's take a look. So right here, compute these following derivatives where I have, here's u of t and here's v of t and so forth. So what we're doing here, the derivative of v of t squared, so I'm going to use my chain rule. So that would be, remember, v prime of t squared times the derivative of t squared, so that would be 2t. Right? So I would put multiply by 2t out to the side, but I left a little space, so I'm going to put that 2t right here. Hopefully maybe you left a little space too. All right, so we're going to use this information up here to do that. So let's see, v prime of t is going to be, derivative of sine is cosine. Derivative of cosine would be sine, so 2 sine, negative. And cosine here would be negative sine. And just while we're at it, u prime of t, in case we need it later for the next one, the derivative would be 1, 2t, and negative 3t squared. All right, but for now, all I need is this guy. So I got 2t times the derivative of v with t squared put in. So what we're going to do is I'm going to put a t squared in all these spots, and then I'll have my answer. So I will say, let's see, cosine of t squared, negative 2 sine of t squared, and the negative sine of t squared. And that's it. So another vector. And so of course you could multiply the 2t with each of these things. So we'll go ahead and do that, but it doesn't really matter that much. So let's see, I'd have 2t and cosine t squared, and then negative 4t that would become, and then sine of t squared, and then negative 2t in front, sine of t squared. So I guess you would like to have the vector all together, so it would be good to like multiply that in there on second thought. Okay, so notice that the answer is another vector. All right, so my dot product here. So this is going to expand into u prime of t dotted with v of t plus then u of t regular dotted with v prime of t. Now notice, when you do a dot product, you get like a number for an answer. Now we're not going to have numbers because I don't have what t is, but it's going to be an expression, not another vector, because these are going to be two expressions added together. The dot product is an expression plus another dot product, which is an expression. I'm going to add them up. All right, so u prime of t, we found that earlier. That's going to be 1, 2t, and negative 3t squared, dotted with v of t, so the original v, so sine, 2 cosine and cosine, plus then I have u of t, so I have original u is t squared, and negative t to the third, dotted with v prime. I don't have space, but cosine t, negative 2 sine t, and negative sine t. All right, I'm going to move over here because we got a lot coming here. So I'm going to be multiplying, right? I'm going to be multiplying this by that, plus this by that, plus this by that, and same for the back. All right, so 1 times sine, so I'm going to get sine, 2t times cosine t, so plus 2 times 2, so 4t cosine t, and negative 3t squared times cosine, so negative 3t squared cosine t. So you just have to be careful not to make a mistake here. And for the back, I have t times cosine t, so plus t cosine t, then t cosine t, then t squared, negative 2. So negative 2t squared sine. And finally, negative t to the third, so it'll be plus t to the third sine t. All right, so let's look for any common parts that I have here. So it looks like t cosine t. So I got one here and one here. And then, oh, nope. That's it, right? So those are the only two parts that can go together. Not exciting. So I got sine t, 4t cosine t plus another t cosine t. So I have plus 5t cosine t. And then the rest of them are all just separate. Minus 3t squared cosine t, minus 2t squared sine t, and then plus t to the third sine t. And notice that's a scalar, right? It's not another vector. And this one up here was a vector. Okay? All right, so our last little thing here, right? Yes, I think this is the last page. All right, so let's just finish this up so that we can be done here. So if you're doing an integral, if you want to do the integral of a vector function, you basically just do the integral of each part. So for the I part, you do the integral of same boundaries, a to b, of the first function. And then you do integral of the second function, so called g of t. And you do the integral of the third function. So just like you did the derivative, you do the integral. That's h of t. Okay, so, and this is just part right here. It's just talking about the fundamental theorem of calculus. It's extended to cover this. And so basically that's saying, you know, you plug in b, then you subtract when you plug in a, and so you can get your final answer. All right, so we're going to do our integral here. So I do have boundaries, 0 to pi over 2. So if I want the integral of r of t, I basically do the integral of 2 cosine t dt, and that's from 0 to pi over 2. Then that's my I piece, plus then I have my integral from 0 to pi over 2 of sine t. That's my j piece. And the last part, integral of 0 pi over 2 of, looks like 2t. And there is my k part. All right, so here is this is my integral of RT from 0 to pi over 2, right? Okay, so we're just going to answer here. Integral of cosine would be sine. So I got 2 sine t, let's see, from 0 to pi over 2. And then over here, integral of sine would be negative cosine. So I got negative cosine, 0 to pi over 2. Remember, that's the j part. And integral of 2t would be 2t squared over 2, so just t squared from 0 to pi over 2. And let's see, that's my k part. All right. So Let's see, pi over 2. The sine of pi over 2 is 1, and the sine at 0 is 0. So I'm basically going to get, I'm going to put this in this format here. I'm going to have in this first part, I'm going to have 2 times 1 minus 0. The second part, I'm going to have, let's see, negative cosine of pi over 2. Cosine of pi over 2 is 0, minus a negative, so plus cosine at 0 is 1. And then the last part, I'm going to get pi over 2 squared minus 0 squared, so minus 0. Okay? All right, so in the front, I'm going to have 2. The next part's going to be a 1. And the last piece, I'm going to get pi squared over 4. And so there is my integral. 2, 1, pi, yep, correct. Okay, so don't do this homework yet. All you have to do is watch the video, and I'll see you in class.